Okay. What did we cover in the last session was what are the various ways of moving data in and out of db2 system other than the traditional select or insert options. So these are the three options we looked at. One is export, another one is import, third one is load. We covered only export and import, right? What does export do? Yeah, guys, please go on mute. What does export do? Export takes data out of tables and puts it in either in the form of flat files or binary files. What does import do? It's the opposite of export. The one we are going to talk right now is a load utility, which also does the same thing as import, which also takes care of data loading, as the name says. Then what is the difference between import and load? The major difference between import and load is speed. If import takes 30 minutes to load data, the same data can be loaded using a load command in like 4-5 minutes, right? But it comes at the cost of integrity. I'll talk about that. Speed comes at the cost of data integrity and lot of pain. So load is not that easy to work out, but it's worth going through all that pain because of the time it saves. If you are talking about overnight ETL loads or something, when we are running against time, load is the best option. Now let's look at what is load. The load utility is another method to populate tables with data, of course. This is the major difference between load and import command. Always try to compare whenever we see load with the import, how it is different from import. The referential integrity and table constraint checks and triggers invocation are not performed by load utility. What this means? As an application developer, when I design table or a schema, the database design involves uh, various table relations, right? The whole concept of database system or relational database system, that means the tables are related to each other. For example, you have let's say a student table, marks table. So student and marks are related. How? Student has a primary key, marks is using the same primary key, and marks might be having this has a primary key, of course this has a primary key, this has a foreign key or a referential integrity. We know this, right? When I say referential integrity, for example, if I insert 501 Prashant, 502 Chandra, 503 Vasu, when I'm inserting data into marks, I cannot insert any record other than this 501, 502, 503. What happens when I'm trying to insert 504? The record does not exist in the base table or parent table. The referential integrity will throw an error saying that you cannot have a data in a child table without having a record in a parent table. This is one of the fundamental ways of keeping data integrity from application standpoint of, right? So you come across this referential integrity in pretty much parent-child relation, right? So this is very good from data integrity, but very bad from performance point of view, right? Because for every record you insert in a marks table, whether it is through insert statement or import statement, it is going to check for respective record in a parent table. You see how pain that is. For example, if we are doing an import, I'm talking about imports drawback here. When you are trying to import, let's say 1 million records into marks table, for every row you insert into a marks table, for every row, the import command will go and check for necessary record in student table. I mean the parent table. As long as table is standalone, it's very easy. You have no concerns. But when table is part of these kind of parent-child relations, this is the first example. Referential integrity, right? For every record you insert in a marks table, it will go and check the student table. That means it will go and scan the student table 1 million times. That is where import is very slow, very slow, right? That's the point we are talking about. This slide is talking about here. Referential integrity is the first point, or it is going to check the table curves, right? Sorry. Um, or any constraints the table has. For every row you insert, it will go and check the constraint. If there is a trigger written on the table, for every record you insert, it will check the trigger, right? This is very good from a data integrity point of view. But the question that load asks is, why do you have to check for each and every record? Why cannot you check at the end of the data load? You see the point? If I am importing 1 million records, why to check for 1 million times in the student table? Why can't I finish entire data import, and why cannot I check only at the end, one time? Instead of 1 million table scans, just one scan. That's the question that load asks, right? But that brings the complications such as, what if load fails in middle? What if import fails in middle? What happens to the state of a data, right? But when import fails in middle, your data is absolutely perfect because you are checking at every row, right? But we are trying to ask ourselves that why to check at every row? Let's do a check at the end in one shot. But that brings up other complications, that what if the import fails in middle, or load, the data load fails in middle. So that's where actually the load comes into play to handle the scenarios. The syntax is very simple. Load from, the same as import from. Table name, the data file of file type, messages into a target table. Load comes in 4 different operations: insert the data, replace the data. Only 2 major options, and the 2 are, the terminate is if the load you want to terminate, there is currently a load running, and if you want to terminate. Load failed and you want to restart the load. If you look at, there is nothing called insert underscore update. Import has that option, insert underscore update. So this different formats this load supports is delimited ASCII, IXF format, and cursor format. Cursor is something that application developers just uses to load the data within 2 commands like this. Declare cursor. Cursor is a standard way that application developer uses to refer an result set, like this select clause. Just use the select clause and insert into the new table. Another important point with load table is the target table must exist before load utility starts. There is no option called create into. There is no such option called create into. Now we frequently compare this. Okay, let me put it a little tabular format here. So let me write it here, import, and just say load. The first thing is referential integrity. Checks for every row, but load checks only at the end. The same thing for triggers. The same thing for and also triggers. Now what is the other thing? There is nothing called insert underscore update. Import has, if the row already exists, it updates it. Load has no such option. Create table during data inserts. Import has that option, yes, but load has no such option. Right, we'll keep adding it. There are 4-5 other differences comes. But before I move on, any questions so far on the slides?
So I have some a question regarding this terminate option.
Go ahead.
Restart makes sense because if the load fails, you want to initiate the load again, right? How does this terminate work? Like, what is the usage of this terminate and how it is helpful in case of load?
Just hold on that till the next slide. So I'm talking on the next slide. Okay. So let's talk about these 4 different modes. The insert mode, it's a self-explanatory. It adds input data to table without changing the existing table data. Replace option deletes all existing data from the table and populates with input data. The terminate mode terminates the load operation and rolls back to the point in time at which it started. One exception is that if replace mode was specified, the table will be truncated. Now, before you understand that, let's look at the restart. The restart mode is used to restart a previously interrupted load. It will automatically continue from the last consistency point. To use this mode, specify the same options as in the previous load command but with restart. Now, this paragraph is important. It allows the utility to find all necessary temporary files generated during the load processing. Therefore, it is important not to manually remove any temporary files generated from a load unless you are sure they are not required. Once the load completes without error, the temporary files will automatically be removed. By default, they are created in the current working directory. You can specify the directory using temp files path. Now here comes the other difference. This answers your question. Temporary files storage. Import uses temp tablespace, but load uses current working directory or temp files path flag. Right. Now to answer your question, terminate, what load does is you started a load on a table, right? And let's say you are inserting 1000 records and your load failed after 500 records, right? Now the load, though that intermediate data of 500 records loaded and everything is stored in this flat file. Now what it does in middle is it actually changes the table state from normal to load pending. So this is anyway, we'll see it through example. So let's say you are loading into student, or let's say marks. This is a child table. You said that load from temp marks.del of del insert into marks. So you have 1000 records trying to load. right? This is a child table, right? What load does, instead of checking referential integrity for every record, it tries to check referential integrity at end of the data load. So load first row, this is how it works. Load second row, load 500th row, load 1000 record or row. Now check for referential integrity for all above 1000 rows loaded. Check for any triggers. It does the stuff. This is the all the operation try to happens in a single commit. The load operation. Now what I'm saying is there is a failure happened here. Right? The load failed in middle. Now all the information of what records loaded will be loaded and temporarily kept in this temp files path or current working directory. Now what happens is the table state of marks will be normal here, right? It will be normal at the end here. But if it fails anywhere in middle, your table's state changes from normal to load pending. Right? Why it won't be normal? Because these 500 records loaded or 499 records loaded, you are not sure of their integrity. Why? Because you loaded into child table, but you never checked the referential integrity. Because you wanted to check at the end. That is a load algorithm. I know it's it's a too much of if and else's. Yeah, but this is how load works. Right? You see what I'm trying to say? If a load fails somewhere in middle, you are in a real mess. So that's why you have to really practice this in a non-production environment. So it's not just straightforward that okay, this table I want to add to the load. No. If someone is asking you to transfer a table data from production to non-production, always use import. Unless you tested that in load and you are confident, don't get into load. Because if it works perfectly. If it fails in middle, yeah, we'll go through that exercise. And that exercise is written with all the complications. The table state will go from normal to load pending. Now bringing this out of load pending, because this 499 records are already on marks table. Because even though without you commit, they exist there. Now you have to run a command called terminate. Right? To take your table state out of load pending for normal access, you have to run the terminate command. Yeah, we'll see that in more detail. Right? But that is the high level view.
So Ravi, this terminate rolls back the 499 records?
Not really, but that depends. That depends. Yeah, I'll walk you through that with example. Right. For now, assume that yes, it does. But there are certain scenarios it really messes up the things. Right. The restart starts from 501 record or 500 or 501 record. Yeah, for now, terminate assume this as it does. It does roll back. Right, but the worst case scenario happens if someone deleted these temp files. It does roll back only if you have these temporary files generated. For example, you ran a load overnight, Usha. You went home, you came back in the morning and realized that okay, load failed. You want to terminate the load because table state is moved from normal to load pending and normal users cannot access the table. Okay. Now, when you are trying to do a terminate, some cleanup job ran in the morning and cleaned up this temporary directory. That's when you are in a mess. Terminate won't work, right? It's because it is not storing this in a temporary table space. It is storing on a flat file. So as long as you have this, yes, you can terminate it back. Right. So let's move on to another confusing slide. A load command works in 4 different phases. The first phase is load phase. It loads all the data in one shot, then creates the indexes in one shot, then it builds the data, then index copy phase. Before we understand these 4 phases, let me walk you through an example. Now let me explain you to this example. This is my load command. Load from, you give a flat file. Where do I want to write messages? Modified by, I am giving a dump file. Now I'll explain you why I need this dump file. This is a flat file. This is a temp files path. Where do I keep these intermediate load files? I'm inserting into employee table. If there are any exceptions, write it into employee exception table. You see, this is full of inputs only. You have to give a file here. You have to give a file in the second line. Third line, you have to give a file. Fourth line, you have to give a file. But fifth and sixth lines, I gave a table. These two are table names, employee and employee exception. So watch out for this. Why do I have to give 4 files and 2 relations? Now my objective is to load, let's say, this data, employee.ixf data, into employee table. Don't worry, this is IXF, but still it's written in English language. Plain readable language. So my objective is to load these 3, 6, and 8 records into employee table. Now what load does is, it checks for any records in these 8 rows that violate table definition. When I say table definition, if you look at employee table, the definition is this is a unique column and the last column must be non-null and numeric. The employee table only accept numeric column here, which should be not null. But if you look at out of these 8 rows, I am trying to store row number 2 and row number 5 non-numeric data, right? So the first thing load does is, even before you actually load into employee table, it throws this data out, saying that you are not fit for this table because you are violating the basic table definition. That is a data type definition itself you are missing. So it writes this 20 hyphen and 40x. This is not 30, this is 40x into a dump file. That is the use of this dump file. It's just a flat file, like probably you can think it of as an exception file, right? The bad data, right? Even before loading into the table. So it just moves from these 2 records from this employee.ixf file to employee.dump file. That is a use of this dump file option. Now, what it does later is it just blindly loads rest of all the data into employee table. Remaining 6 records, it just blindly loads in one shot. Just select it from here and insert. Then it starts checking for these constraints. We discussed here, right? When does the constraints go for check? At the end. After I load all the 10 records, that's when it goes for constraint checking. What is one of the constraint I have here? Unique constraint. So it loads 10-1 here, 20 is into the dump table, 33 it loads, then it also loads 34, Now this is where at the end when it is checking, okay, I have two duplicate records, 30 and 30. So it loads the second one back into an exception table. The use of exception table is to hold any exception records. The definition of exception here is which is violating the table constraints or referential integrity or triggers that kind of an temporary bad output. So here also 56 and 57. So 57 is kept it here. So out of 8 records, 4 only actually loaded into the table. 2 went into a dump file and 2 went into a exception table. If you can also ignore giving this exception table and dump file. These are not mandatory. If you don't give, this information is nowhere tracked. It is just gone. You are trying to load 8 records, but only 4 records exist in the employee table. What happened to the remaining 4 records? You have no clue. Right? Now, let me explain one more time quickly and I'll take questions. So load just works like import command. You have to give a flat file where you have your 8 records, right? All the load operations, the message log is messages. This is just a log. when there is a bad data which is violating table definition itself. For example, inserting a character column in a numeric data is a table data violation. Data type violations, it will be written into a dump file. It's a flat file. But rest of all the data is loaded in table. Before actually committing, it checks the data integrity in one shot at the end. For example, the first column must be unique. So these two are violating unique definition here. So it loads these 30. Look at the colors. So you see the color coding. 34 is moved to exception and 57 is moved to exception. So in summary, if I'm trying to load 8 records, 2 records are in the dump file, 4 records are in the table, and 2 records are in the exception table. Right. So any questions on this? It's too much of an information. Import you don't have to worry because it just goes line by line and it does its job. Like I said, if you are not against time, just simply go for import. Right. But what happens is, on what scenarios I go for load is overnight ETLs, where I have only 6 to 8 hours window to finish up data loads. So that's when you depend upon load.
So Ravi, question here. So if for this same kind of table, if we are trying to do an import.
Okay.
So again, I'm a little lost here. Actually, I didn't pay attention, to be honest. Okay. If we are doing the same kind of data with import, here like we have sorted out everything. We have the exceptions and the data which went into it. It took care of the integrity, right?
Right.
But for the import, it doesn't check for integrity.
No, it checks line by line. Every record you insert, it checks.
And in the case of when it encounters, say this the 34, what happens?
30 space 4. My guess is import won't add this. There is something called warning code. If I go back here into the import.
Sorry, actually I fell asleep.
No, sorry. I know it's too late there. There is something here called warning count in an import syntax. So by default, the warning count is 1. That means the moment you hit the first error, stop there. Right? So the default behavior of import, the moment you see any bad data. For example, even in the second record, 20 hyphen.
Okay.
It just stops there.
It will stop.
Yes, but generally that's not what we do. Whenever we are loading any or importing any big
This kind of
data,
data, say.
yeah, we say that warning count is like, okay, I'm okay till 10 errors. I'm okay till
Okay.
20 errors. Till it reaches those 10 errors, it continues
Okay.
the import behavior. Right. So to
Yeah,
answer your question,
yeah.
import stops right there.
It stops there. That means it doesn't, the table is not updated, or it updates till the first 10 errors.
Right. It updates till the first record.
Yeah, whatever limit we give.
Right. But the good thing is tables is still accessible after import failure as well.
Mm-hmm.
But load, no.
Yeah, I think probably we should do the same kind of data with load and import and see how they differ.
Right.
To get some
Right. But
clarity.
unless we are talking about GBs of data, don't get into load. Right.
Yeah, I know.
Import
For
is, yeah.
practice.
Yeah, import is, yeah, for practice. Like, yeah.
Okay.
Okay. Now, I will quickly talk about this exception table. Exception table is same like your original table. For example, if I have a T1 table, we simply create an exception table as a T1 exe. But this exception table has two extra columns, timestamp and message. This is a standard syntax that you have to give for the exception table. So what is this exception table? You are giving this exception table in a load example, right? So along with the table data, for example, 34, it adds this timestamp saying that when this data is loaded, for what reason. The message says, is it violating unique constraint? Is it violating foreign key constraint? Is it violating primary key constraint? That kind of an information itself tells us in the message, right? That's why if you are creating exception table, it's as simple as creating a table with the same columns plus two extra columns. Now quickly look at this slide, then we'll go, I'll walk you through my lab exercise. So import very slower on large amounts of data. Load, if it's a faster on larger loads, it's very faster. Creation of tables and indexes with AXF format. Yes, I can create a table in import, but load, no, you cannot. SSF format, worksheet format is supported here, it's not supported. What happens with the import is every row I insert, it goes through a redo logging or a transactional logging, right? But that is not the case with load, right? This is where the data integrity comes into. Now let me explain you this. This is very important thing for DB. Now my time is 7:43. Okay, let's say at 7:30 I started import of 1 million records, right? So every row I insert, it goes through something called transactional logging. Now at 7:30 I have a full backup, right? At 7:31 I started import of 1000 records. Now this import completed at 7:45. Now what happened around 8 p.m.? I have a crash. I have no option other than restore. Now what do we do as a DBA? So the crash recovery is not working, so we have to go for physical restore. So the physical restore involves two different things, right? One is backup restore plus apply logs. So when we go back and check what is the backup we have, yes, okay, luckily till at 7:30 we have a backup. So the strategy is apply full backup taken at 7:30, then roll forward logs from 7:30 to 8 p.m. It's a standard, right? You know, there is nothing specific to db2. In any database you do the same thing. You restore the full backup taken at 7:30. For rest of half an hour you just roll forward, right? So you won't find any problem in import, because even though import happened, every record you import will be written into the transactional logs or a redo logs. But the problem happens when you have a load. Right? Probably this might have finished in by 7:35. The same scenario happened at 8, crash happened, and your physical restore of backup restore for apply logs. You apply the 7:30 backup. On top of it, you are trying to roll forward logs. But here is the problem comes with load. Now load does a minimal logging. Load does a very minimal logging. Probably what it stores is I'm inserting 1 million records into marks table. That's it. It does not store what records it is inserting. You see what I'm saying? That is the difference here. In import, all rows are logged. In load, minimal logging performed. Now if it does not have what it has loaded, how do I recover? You cannot recover. The point is, if I cannot recover, it's a question of data integrity. You see, right? If a crash happens, you know, someone loaded 1 million records on production, I cannot get back those 1 million records. Why? Load does not log this data. Load just says that, okay, at 7:31 someone is trying to insert 1 million records. At 7:35, yes, someone inserted 1 million records. That's it. What is actual data, like import records in your redo logs, transaction log? This guy doesn't. So it is your responsibility to keep this file somewhere. Whatever is a load input you give as load marks from whatever is the temp marks.ixf. It is your responsibility to keep this file. That's why I will walk you through the example. Okay. Now the point is, yes, we all say that okay, load is super fast. You know, here instead of taking 15 minutes, my load took only 5 minutes. But what happens if a crash happens after that? Am I going to? But see, we promise this, right? You know, the ACID properties of any relational database. Once I commit, we say that it must stay in the database. But load is a risk.
Ravi, this is Vasu. Just one quick question. See, it says it's completed by 7:35, right? It doesn't matter whether you logged in or not. Whether you're logging or not is not important, because you already completed the task at 7:35. Only at 8 you want to restore. That means you already have the task finished. But if you're crashed in between 7:35 to 7:31 and 7:35, in between 7:34 or 7:33, then you won't have the log, right? So what I'm missing, that's what I understand.
Okay.
No other databases.
When I say crash here, I'm talking about data files gone. You know, when you commit, you write this information, let's say, into the some flat files, right? Something like U01. So container 1.lrg. The information is here, right? What I'm saying here is when I say crash, the physical crash where you lost these data files are corrupted. We have written this data into the data files, but what if someone removed these data files? You see the worst case scenario, sir.
Okay, so basically you don't have the backup after that. That's what you're trying to explain. So you don't have anything in between, so you cannot go there.
No, it's not about the backup. No, it's not about the backup. When I take the backup, where the backup gets stored is somewhere.
So let me ask this while you are in this. See, anytime when you are restoring in either Oracle or SQL Server or any database, before it restored, the first and foremost thing it will do is called tail log backup, right? So it does the backup of where you are to make sure that if something happens even in the restore, it will to recover. So before it restores, it will do a backup.
Okay.
You know what I mean?
No.
Then when you are doing that, means your starting point will always have a backup to the point where you are. Unless, I mean, if you lost something in between that nobody can do, but it will start with a restore only. The restore starts with the backup first.
Right. So that is the backup we're talking about here. At 7:30, I have a full backup. Right?
Yeah.
Okay. So here we are talking about a scenario where your data files are gone. The whole table spaces are gone in other sense. Okay.
Yeah, I mean, okay. So you cannot, even if I do a tail log backup, there's nothing I can recover because it is already lost. Okay, I see what.
Right. Now, we have to go to backups, we restore backups, but we luckily have the transactional logs. Because the redo logs are transactional logs. We keep multiple copies in multiple file systems. So that's when you have to apply all the logs one after the other, right? The transactions. Okay. Now, import keeps track of each and every insert or update happens, but load doesn't. Right. How do we solve this problem? Yes, it's our responsibility to keep this load file externally. I'll walk you through the example. So let's quickly look at other differences. Import triggers will be fried. Load triggers are not supported. The temporary space is within the database for import. Temporary space used outside the database. Right. The statistics are not run. For import, you have to run the statistics. We haven't seen the statistics, but these are gathered. So, the major thing here is the logging, right? That's actually the question of data integrity. Now, let's go through the exercise. Let me walk you through the exercise, then it all makes sense or all add up. I mean, this is just a blind steps. I'll just blindly follow this, okay? Which I expect you to do the same thing initially. Two prerequisites I have for db2 load is I'm making sure that below directories exist. Let's see if I have mount storage utils. Make dir mount storage utils. So let me switch to root. Some directories, couple of directories, nothing else. Make dir -p mount storage utils. Let me change the permissions of these two directories. Now I'm creating two files as customer.unl, and I'm loading these four records there. Similarly, sales.unl, because these are the two tables I'm going to create. down the line. Okay. So prerequisites steps are done. Then what I'm trying to do is I'm trying to create a database, right? We don't create a database now, or let's create it. But we can ignore this because the database creation takes some time, like a couple of minutes. Now let's create it. Okay. Let's go by step. So what is this create database command does is I have to be a root. Sorry, I don't have to be a root. I have to be a database owner. So I'm saying that create database utils on mount storage utils. Those are the directories I created, and also the db path on the same directory. This we can give it in a separate directories. Now after this, I connect to the database. I list table spaces. I should see 3 or 4 table spaces. Then I create a new table space called test util, which is managed by automatic storage. I can ignore this managed by class because it's a default one. So then what I'm doing is I'm updating this transactional log. So we haven't spoken on transaction logs, but for now, just follow these steps. This is a redo log, transactional log. All the changes, intermediate changes will be written there, right? Now this is where the fun starts. So I create a customer table, then I create a sales table, then I'm adding a primary keys to both of it, then I'm adding a referential integrity to sales table. Initially both have 0 records. So when I'm trying to insert into sales, it will fail because sales is a child table. You cannot insert a record into child table without a parent. So how do I check a table state is load query table name will give me the table state. Initially both tables are normal. This is when I try to load these 4 records and 4 records that I created. You see I'm trying to load 4 records into a sales table, that is just give me 1 second. So this is what I'm doing here. I'm loading into sales table. See, this is the mistake I'm doing here. It's not really a mistake, you can also do like this. I'm loading into a child table, right? If you see this load query table sales, the table states set integrity pending, right? It actually kept the whole table state from normal to set integrity pending. When I say set integrity pending, buddy, you have to check the integrity of the table because I'm not sure of the data he loaded. Then you have to run a command, set integrity for sales immediately checked, right? But the problem with this is it puts the whole table space in a backup pending, right? This is one of the worst things it does, right? Okay. So since we are talking about here the recovery scenario, right? Since you have done some load here, you have to take an entire table space as well, table space backup after the load. But there are some ways we can avoid it, right? But let's go by step. Our table is created, right? It's a very lengthy exercise. I'll try to finish up in next 15-20 minutes and we can cover the questions, right? So then I'll try to connect to utils. Then when I say list table spaces, you see I got 3 table spaces, and look at the table space state. 0x0000 means it's a normal state. Now I create a new table space like this. If I list table spaces, you should see the new table space also created as a normal. Now let me update. So this log arc method one is a parameter which holds. I'll explain you this in next classes when we talk about backup and recovery. This is a place where we have a transactional log, the logs that are needed for recovery. I say that db2 terminate. So for this parameter to take effect, you have to bounce the database. Bouncing the database in db2 is nothing but activating and deactivating database. I am not doing anything out of ordinary here. I'm just following the steps given in this, right? But after deactivating and activating, since I have changed an important parameter, it is pushing me to take a backup, right? I cannot activate the database because the backup pending state is on the database. So you can also see this database level status. So backup pending, yes. You haven't learned backup pending, but this is a simple example. Just backup database to /temp. The output of any backup database statement is a single file here. Now after that, this is all a groundwork, right? Groundwork for actual load command. Now if I am trying to activate, yes, it is successful. Here it failed, but now it is successful because I have taken a backup. Now let's get into the actual load operations here. Now let me connect to utils database. So before that, I say the db2 here so that I'll get into interactive mode. I am just blindly following the steps. This is what I expect first time. When I say list tables, I don't have any tables here, 0 records. That's when I create a table. I'm creating a customer table in a tablespace test util. Then I create a sales table. Again in the test utils tablespace. This is when I add constraints. I'm adding a primary key to customer table. I'm adding, I believe you know, this is all something that done by developer. So we just building our ground. I created a primary key on customer. I created a primary key on sales. Then I made sales as a referential integrity to customer. If I say list tables, customer and sales. Now if I run some data, there is no data exists now because I just created the tables, right? Now what I try to do is next I try to insert into a sales table. Now I get the error. I cannot insert into a sales table. Why? It is clearly saying here there is no equal record in a parent table. Okay, there is no equal record in a parent table. That's the error I am getting because it's violating the referential integrity that I have built here. Because there is no data in customer, when I'm trying to insert a record into child table, it is failing. This is the insert behavior. This is how even import works. Import is nothing but a bunch of insert statement one after another, right? So let's also understand how do I check table state, load query table sales, load query table customer. Both are normal and normal. When I say normal, you and I can query, right? So this is where I have the data. Let's double check the data one more time. Right, we have the data. Now this is where I run this load command. The insert failed to sales, but load will be successful. So it says that 4 records read, 4 records loaded, and 4 records committed. But the interesting thing to watch here is check the sales table state. The table state earlier was what? Normal. Now it is set integrity pending. Buddy, you asked me to do a load, I loaded. I am not sure of data. It's your headache. That's the loads command behavior, right? So if I check here, the load command status is the table status is normal, but since I loaded into a child table, it became set integrity pending. I mean, there is a simple command to check set integrity. Set integrity for table immediately checked, but this will also fail because set integrity for sales immediately checked. The table space access is not allowed. This is the nightmare situation we can have, right? When you load into a table, the table space also will go into a backup pending. Now, if you say list table spaces, you see all the states for this. These are normal, except this guy. You see his backup pending. I had this scenario once in production. The table space unfortunately was of like 750, 800 gig. It was like a complete downtime for the table space in production for 4.5, 5 hours. So we have to be very careful when we play on load. Load not only messes up the table state, it also messes up the table space state. There is a way we can avoid this, okay? Right. So when you say the list table space, this is what I showed you. Now what we are saying is we have to take a table space level backup. Backup data. You don't have to back up entire database, just a table space. To device null, operation not permitted, connected in the database. Okay. Let's terminate. The operation failed because specified database cannot be connected to in the mode requested. Why? What is the error it got here? 57019. Deactivate database. Okay. db2 list active databases. So the utils is an active database. I have to deactivate it. Then go for the backup. You know, if any error, it's expected. It throws an error message here. You can check the information about this. A question mark and just pretty much 99% of the times it gives help here. That is useful. So let me put it here that you have to deactivate database utils, then take the backup. Now backup is successful. Now let's go back to the db2 prompt, connect to utils. Now check for the table spaces. Oops. Now if you see these test utils here, it's a normal state. But what about our load query table sales? It is still in set integrity pending, right? Even though taking a table space backup did not help my sales table. Why? Because there is no data in a customer. Now even if you run the set integrity, it won't help. It will still fail because there is no data in a customer table. This is when I have to load the data into a customer table. Now load the data into a customer table. Load query table customer. But you see, customer has no such problem. Customer table state is normal, right? But like I said, whenever you do any load, the associated table space will be coming backup pending. Remember the blind rule. Whenever I do any load, whichever is a table space the table belongs to, the table space will go to backup pending by default. Now again I have this pane. I have to take this. Right. Now if I connect to utils, now if I check for the customer load query, now if I check for the load query table sales, so I can run this integrity. I'm sure you guys have no clue what's been happening here, but yeah, right? If I have a load query table sales, now sales table is back to normal state, right? So if I'll give you some shortcuts at the end, right? You don't have to really go through all these pen, but remember, if you don't do any special care while doing a load, you have to go for a table space backup. Right. Now here comes the best practice. To avoid backup pending for table space, see, if table space is like 4 GB, 5 GB, you can play taking backup. If table space is 1 terabyte on a production, the different people cannot access the table space, right? Now the thing you have to do is load from so and so, insert into so and so. You have to say an option here called copy S. There are two different ways you can avoid taking a table space backup. There are two different ways you can avoid putting your table space in a backup pending. So let me write it here. So whenever you do a load, there is a chance that table goes to non-normal state plus table space goes to backup pending. To avoid this, to avoid the table space going to backup pending, you cannot avoid this. You have to check the integrity. To avoid one, you have to do set integrity. But to avoid table space, the bigger guy going into the backup pending and stopping entire production from accessing, the load has two options. One is you have to say copy S. Second one, non-recoverable. Now, when I talk about the non-recoverable, you are explicitly telling database instance that, buddy, I know what I am doing. You don't worry about backup pending. In worst case, if a crash happens, it is my mistake that I did a non-recoverable, right? So it won't put back in a backup pending saying that it's your risk. You are taking the risk, right? But here, what happens in a copy S is you physically store the sales.unl file in a temp directory. You keep a copy of it somewhere. What happens if you keep a copy? In worst of the worst cases, when you are applying the logs, it will redo the entire load from this temp. It will redo the entire load from temp. You see what I'm saying? Okay. Now, let me do this once quickly. Let me try to load the data into sales table one more time. Right. If you look at the load query table sales, it will go to set integrity pending. Let's see the list table spaces. The test utility table space is not in a backup pending state. Why? Right? Why? Because I used an option here called copy S. What happens when I use a copy S? It will keep a file here. This is the data you loaded. This is the data you loaded into the sales table. .4 means it's a data written from load command. Just in case, if I go back to this scenario here where the crash happened, even the load does a minimal logging, you have a full backup, right? Even though it has a minimal logging, the record of these 1 million records load is stored in the temp, so it will redo the load. Your restore time might increase, the recovery time might increase, but you don't lose the data, right? That is why this is a very important scenario. By default, if you are not sure of a load as a newbie, what we do is we ignore using the copy S option or non-recoverable. That means indirectly you are digging our own ground in a production. You have to go for a backup of a table space, right? So we must not miss this copy S. Okay. So my expectation is you walk through this and do these exercises. Whether you do exercise 2, 3, 4, 5 or not, just exercise 1 must be done, right? If any questions, we can address that in after the exercise. We can address that in next classes whenever you feel comfortable. But we must practice this. Okay. There are 5 exercises. I kept it here. One is the load command. See, sometimes students ask me that is it really worth going through all this pain? Yes, it is worth when you are against time, right? So not just here, you go to anywhere, any database. If you want a speed, you should not check all those constraints or all those referential integrities, all those triggers record by record. You just load in one shot and at the end try to check. And we all know logging is the biggest culprit for slowness. So they have to avoid logging. But what if data integrity comes into picture? That is where we are storing the file. The complete load file, you are storing it using an option called copy as. Just in case if you want to redo the work, you get everything from a temp folder. Right, if someone removes that file, there is nothing you could do. That's why you have to safeguard this in some temporary directories. Makes sense. I know there would be so many questions or confusion for sure on the load, right? Load is not an easy thing, right? But remember, when you are using a load, even if you don't understand, make sure you have this copy as option. I recommend not to use non-recoverable. That means you are indirectly saying to the database instance that I know if a crash happens, this table won't be recovered. That's it. Now don't do that. Always say copy as. And make sure this directory is safeguarded. Right.
So we should set copy tablespace in copy as mode, right? Not the second option, not recoverable.
Not non-recoverable. Copy S means the load data, whatever you are trying to give as an input, the sales.unl. The copy of this file is stored in this temp directory, or what other directory I give here.
Right.
Right.
What does this do? The second option?
Which one? This one, non-recoverable.
Yeah.
Yeah. It neither logs nor stores the file. So in worst case, in this scenario, what happens? You don't have a logging. You don't have it stored somewhere. So that means your table will be in a inaccessible state even after the recovery.
Okay. Oh.
I mean, it's such a pain. I know. The load command.
It's not that simple. Load
It's
is
not
not
that simple.
that simple.
Yeah, but just remember to use copy as option. That's it. If you are confused in using the load, just remember the copy as option. That's it.
Okay.
You are safeguarded.
Yeah, but it occupies a lot of space on the file system.
Right. So whatever the file you are loading, you will keep a backup copy.
Yeah.
Now system knows in worst case where to go and redo the load.
Okay.
So the rest of the exercises talk about some of my practical scenarios like export, import. Before that, how do I enable, disable constraints during the load and all that stuff.
Okay.
Sometimes it's important to check what other tables need integrity checks in one shot. Sometimes what happens is this is a common scenario. If I load it into one table, here we are just talking about customer comma sales, right? Sometimes we don't know this referential integration. If I just load into one table, right? 10 tables goes to set integrity pending. So this is a nightmare situation, right? So load without practice on a lower environments, never ever do it in production.
Right. Yeah.
Okay. So I'll break here for today, right? Tomorrow we don't have a class. I have some semester exams here. Day after tomorrow we can meet. There will be 2 more classes this week. We can also do it session on Friday evening your time, like last week, if you guys are available. All are available. But tomorrow, please excuse me. I have to head early. So next two sessions
Day
we
after
will.
tomorrow, mostly I will not be available, Ravi.
Oh, okay.
Yeah, I'll be traveling. So yeah, I'll join.
Let me get the consent. Okay. Let me see, because the export import load we should not move forward without practicing enough. Okay. Right. All right, guys. I know it's too late there, Usha and Vasu. Sorry to keep you late.
Ravi, where is this the document to this exercise? I want to practice it tomorrow.
It's in the drive.
I'm trying to access. Is it in the April 2018? I can't access.
Yeah. Check the PPTs folder. Yeah, it's there in the PPTs.
Hold on. It's in April 2018.